Hello everyone, thanks for your enrollment. Thanks for enrolling a CCNA DevNet course. You can see the paper code here. And in this course, what I'm going to do that I'm going to cover each and every sections that you have in this particular course. So when you are starting this course, obviously you'll get this welcome video message, this video, and how you can proceed in this course. So in case you don't know Python, then you can go and skip section 1 to 6, directly go to section number 7, where you will get 19 videos related to Python, because Python is very much prerequisite for this particular course. So in case you know, you can skip. Anyways, that is the last section. So you can skip this section anyways. But in case you don't know, then you go and complete section 7.0, section 7, that is Python, and then come back to section 1 and start your learning, your journey from section number 1. I'll understand that in this course, Cisco has divided these sections into 6 different parts. You can see the weightage 15, 20, 15, 15, 20, and 15. Like that, you should understand software development design, API, Cisco platform, and development, application development, deployment, security, infrastructure automation, network fundamentals. With the name, you will not understand what is within these sections and subsections. But at the moment you'll start learning this, for example, if you go within section number 1 and I'll start learning section number 1, you will see that first of all, I have added the topics related to these sections. So you can see that section number 1, for example, weightage is 15%, and these are the topics you have to understand in this section. So likewise, slowly, you can move and you can learn, understand all these sections, subsection, and you can go and complete your CCNA DevNet course. Okay, once again, thanks for your enrollment, and I hope that you will learn new things in this particular course. All right, so let's start the section. In 1.1, you can see that we have to understand about compare data formats, XML, JSON, and YAML. These three are very interesting data format or data structures that we want to understand here. So first, what I will do, I will give you the brief about these common data formats. And then by the end of this video, we have one comparative slide where you can go and check the differences in between these data formats, where we want to use what type of data format. XML, as you can see, extensible markup language. This is using tags in their format, and this is suitable for web services, right? It has the hierarchy. So some interesting facts we have related to XML. Although this is simple data structure, but it is used and it is in hierarchy. It is using parent-child relationship, and it is more verbose than JSON and XML. JSON is something which is used heavily in the web APIs. In the API section, you will see that we will go and use only JSON. So XML is also good. It has some property that is not there in JSON and YAML that we'll see in the summary slides. Let's check the example. Here you can see that we have book hierarchy. For book, we have attributes such as title, author, year, and then you can see that some sort of hierarchy has been used here, that title is Harry Potter. We are opening the title and then we are closing the title. Likewise, author is J.K. Rowling. We are opening this and we are closing it. And finally, we are opening the book and then we are closing the book. This is the simplest example we have, but it has more and more complex examples as well. This is the data format. Next is JSON. This is very much inspired from Java scripting, and this is lightweight data exchange inspired from JavaScript object syntax. This has key and value pair. Key and value pair is one of the data structure format for the Python programming. It is heavily used in web APIs. So you can see that we have key and value. We have key, title, We have key and value. We have author as a key and then the value for that author, year, and the number of that year, right? So again, it is easy type of data structure. It is commonly used in the configuration files data storage, while XMLs we are using to configuring files and data interchange formats. Final, we have YAML, Ant markup language. It is quite a bit human readable data serialization format that it has. It is very much human readable. You can see book, title, author, year, very plain type of a structure, right? But it can have these simple, it can support simple and complex data structure such as list and dictionary. Now let's quickly go and see the summary slide where I can summarize all three. So here you can see the format for XML, JSON, and YAML, and the complexity you can see. So XML, they are suitable for complex data structure, JSON is for simpler data structure, and YAML is in between, like it has a balance between simple and the complex data structure. You can see the examples here in the bottom, and the usability. So usability, you can see that it is used for SOAP, it is used for web APIs, and it is popular for configuring files and automation script. So you will see these examples, you will see these examples more and more. You will see actually in our network automation, you will see mostly the JSON and the YAML format. It is used in different places because of their simplicity and data structure. This is YAML is human readable and visually appealing. This is also human readable. This XML is less human readable. So now you can see that we have all the features and differences in between these data structure, and in upcoming section when you'll go and do some examples, do some lab hands-on, then you'll understand more about these data structure. All right, so let's stop here. Good job. So now we know different type of data formats, how we can go and integrate these data formats within the Python. Python itself is a big topic, and in upcoming days, upcoming videos, we will learn more about Python. At the moment, I'm assuming that you have very less knowledge or basic knowledge related to Python. And just for the integration point of view, we have to understand this section that is there in CCNA DevNet. So what is that? We have our XML data format, right? So this XML data format, XML data, how we can call within the Python. Now here you can see that we are using functions, we are using conditions, print a statement, all those features within the Python. Maybe you don't know at this point of time, but you can check this as an example just to check this, make some notes, and you can proceed, because anyways, later on we have to learn more about Python. So here you can see on top that we are importing package from package XML ET element as ET. Now this ET we will go and use here with function. So now you can see that root equal to ET dot from string one function where I am calling all the XML data. Why? Because this data format I want to use within Python, and I want to print it. So I want to print the book, the title, the author, the year. That's why we are putting everything in the for loop, because till this condition will match, it will go and print all these statements one by one, right? So now you can see that for book in root is what this, and it is calling the XML data one by one, parsing that data. We are finding the book. So it will go and find this XML book. Then it will go and find the title. So this is the title. Then it will go and find the author. This is the author. Then year. It will go and find the year. And then finally we'll go and print everything. So we are storing the title, author, year, and then we are printing it together, title, author, and year. I'll show you this example in the lab section. So let me quickly go there to the lab. Yeah, we have Visual Studio. Here you can see that you can go and install Visual Studio Code, that is free software from Microsoft. We can install in your Windows, your Linux machine. Once you install this, then automatically it will go and integrate all the packages that we have. So here you can see this XML example, the same that you're seeing in the slide. And then we have this Python integration with the data format. Now, if I go and run this program, obviously it will go and print the title, author, and year. So you can see the title, author, and year. So now you can see clearly that the XML format we are embedding within the Python with some conditions, with functions calling, and then it is printing the output, right? So let's go back to the slide. Now, next is JSON. JSON is key value pair. Again, you can go and integrate it within the Python. It's actually very easy to integrate. Now you can see the difference in between this program and this program. It's very easy to integrate, right? So we are importing the JSON data as a key and value pair. So book, within the book identity, title, author, year, same, right? So we have the JSON data. Now this JSON data will go and store within the book dict function. You can see JSON loads JSON data, and then we are printing. Now you can see that we are printing. What we are printing? We are printing book dict, book title, book author, and the book, right? Let me quickly show you this example as well. So here you can see, now you can see number of lines is also reducing, 20 line, and here you have only 7 to 8 line. So here you can see that we have the book dictionary where we are storing the JSON data, book title, book author, book year. Now if I go and run this program, you can see the output, book title, author, and year, right? Likewise, I have third integration as well. Third integration is that the YAML. So YAML data, we are importing the package YAML. Then we have the data format for YAML, and then we are calling this within the Python, very much same like JSON, right? So here booked it, YAML safe load, YAML data. This is the YAML data we have because we have defined the data here. And then again, we are printing book title, book author, book year, very much same that you have here, right? So you can see now some, not similarity, but in terms of programming, in terms of writing the code, we have some similarity in between the JSON and YAML. And that's why these two are very popular. These two are very popular while creating the programs. So now you can see the output for the third program, right? So this is the way that we can go and integrate the data formats within the Python data structure and get the output. Great. In 1.3, we have to understand the concept of test-driven deployment, TDD. Now, in this TDD approach, you can see that you can go and start one test case. Suppose you have to build a big package, big program, but you will not simply go and start writing the code. The principle here is this, that even before writing the actual code, write the test steps. In the diagram, you can see that, okay, we are starting from somewhere, and then we have one feature request. For example, I want to create a program for factorial. So for that, I will go and write the test, and mostly this test will fail because we are writing one part of program, one part of feature, one feature that is requested. And for that feature, I don't have other supported packages and functions. So obviously it will get failed. We will provide minimum script, minimum support for this program, so it will be passed, right? So that's the concept, that you write a program in a way that it should be specific to that particular feature. For example, factorial of 5. I want to write a program for factorial 5 and it should pass. So once it will get passed, then we can go and do the refactor. We want to make it clear program, clean program, reducing the complexity and all. And likewise, we will go and develop a test script. From that test script, from many failures and few passing, and a refactor means the overall optimization of that program. If we go and do that optimization, after that it will be ready to use in the real code, right? So this TDD development, you can see that I start writing a desired code of with any of the programming language. For example, some unit test. The test should fail initially since the code implement the function doesn't exist, that I told you earlier. And then we'll go and implement the code, and we can go and run the test. I'm going to show you all these steps in next couple of minutes. And then we refactor the code, means we'll go and improve the structure, readability, performance, all those factors related to the code, and we'll go and repeat the cycle. That's why we have this diagram here, that you can go create a test. Obviously it will fail, then try to make this pass. Once it will get passed, reiterate and make a stable code. Then you can go and utilize this code within the function. So here you'll see that we want to create a factorial, and factorial of 5. And here you can see that we have the test case, we have the test result. So what is there in the test result? Is this test will pass or fail? You can see that we are defining a function called test. The calculate factorial self factorial of 5 will be 120. So I have the input and the output, right? Factorial of 5 is 120. If it is correct, that means this will pass, this test will pass. If it is not, test will fail. And the factorial function I can have anywhere in my folder. So you can see that factorial function here, it is defined somewhere in my same folder from where I want to run the program. So this is the factorial of 5. 5 means 5 into 4 into 3 into 2 into 1. That should be 120, right? And then if it is 120, it will pass, it will give you success, otherwise failed. So if this particular program will be successful, that means our TDD phase is good, it is working fine, and that's why we should go and use such type of approach. So let me quickly go to the Visual Code. Here we are. Now you can see that I have one program related to test failure or test passing for factorial of 5. The result should be 120. And then I have factorial function here that I am calling. So from factorial, I am calling calculate factorial. The function is calculate factorial, input is n as 5. Obviously, when you go and call this function calculate factorial, it will go and call this function. And here you can see the step. Step number 1, write a test case. Step number 2, this should be 2. Implement the code. Then step number 3. Oh, step number 3, here you can see run the test. Then step number 4, refactor the code, right? And then step number 5, that you should go and do it again and again and again. So let me go back here so you can see the steps that we have. Let me go here and show you that the steps. Yeah, so write a code, implement a code, run a test, refactor, and repeat the cycle. So 4 steps you have, and after that you can go and repeat the cycle. So you can see 1, 2, 3, 4, refactor, and then iterate, right? So if I go and run that particular program with the incorrect, let me go and put incorrect input, maybe 100 here. Let me save. And if I run this program, 3A Python, you can see that, oh, assertion value, why it is failed. Assertion 120 is not equal to 100, and that is failed. And now if I go and make this 120 and save this, and if I go and run that, you can see it's passed. So likewise, we can go and test these test cases or the features, make this pass or fail, and then we can proceed in this TDD approach. In 1.4, we have to understand about waterfall, agile, and lean model. Here you can see that I have added one nested pinning as well, but let's focus on the agenda that this waterfall model, how it is working, how this agile and how this lean is working. So waterfall model is one of the starting strategy, you can say, where it is working on the sequential process, full documentation, a rigid structure. That means that it is suitable for the projects where the changes are less. Unlikely you are doing the changes. But this model is suitable because here you are doing documentation, lots of documentation, design, implementation, testing, deployment, etc. But only drawback with this type of methodology is this, that the flexibility related to changes. Now to overcome this, we have other model. We have agile model where we have the iterative and incremental model. It is flexible. We can do the collaboration, and it is suitable for the project where we have the dynamic changes. Now, one very important aspect in these models, like, okay, you are doing dynamic changes, but with these dynamic changes, how you can go and change it means on which outcome, how we'll go and change certain models. So for that, in these models, we are getting the frequent feedback, right? Because we are getting the frequent feedback, so we can go back and do the changes and make sure that it is, although dynamic, but it is stable. The next model we have is the lean methodology that will do the elimination of waste. Some kind of improvement you can say in the agile model, because in agile model, although you have the dynamic changes, but is still, if you are looking for the elimination of waste, then you can go for lean model, where it is focused on minimizing the waste such as unnecessary process, delays, defects, overproduction, and all those things. Right? It has a value stream mapping, continuous improvement. Right? Continuous improvement is one of the key for the lean model, customer value, and it is suitable for the project focused on efficiency, value delivery, continuous improvement, right? So the agile methodology and lean methodologies are something that you will focus, that you will make sure that you are following these methods to develop the software. Although in some cases you have the waterfall methodology as well. Now you can see the waterfall, now you can see the agile and the lean. Lean, the center of attraction, the focus is the client for the lean model. Let me show you the comparative chart. Now this chart is a little bit hard to read, so let me go next. Now here you can see the chart that we have waterfall, which is sequential, agile, which is iterative and incremental. We have lean, which is focused on the elimination of the waste and continuous improvement. So that's the key. Customer is the focal point in the lean. And apart from that, you can see the main thing, that is the suitability. So if you go and check the suitability, you will find that it is well suited for the requirements. So lean model is suitable for project focus on efficiency and value delivery. Agile, it is ideal for the dynamic and evolving requirements. You can pause the recording here and you can note down these points, although these notes you will get from the recording video as well. All right, let's stop here. In 1.5, we have to understand the code, and that code related to the functions, classes, and modules, right? So while you're creating the code, big programs, these big programs should have some sort of modular approach. So if it is modular, if you will go and define functions within functions, that means the reusability. Then your code should have the readability, means code if someone will go and read your program, he should understand the readability should be there, the version control, the changes should be there, like the maintainability should be there, and encapsulation and abstraction will be there. We know that from object-oriented programming methodology knowledge that codes they are supporting encapsulation and abstraction. Code, they have classes, they have function modules, and that's the reason they can scale. They can scale and they can extend as well. So one package, suppose I will go and create one package program, and that package program later on I can go and merge with other package programs. So that means I can extend my program, and that's why if you go and see any type of mobile applications such as any type like Uber or Zomato, food applications or car rental application, etc., you will see that after maybe 3 or 4 months they are changing their overall interfaces and overall look and feel, and they are adding more features, removing some features, like that. How it is possible? The point here is this, that they have one structure, right? They have one big structure, giant structure, and in that particular structure what they are doing, that time to time they are adding the codes, removing the codes, they are adding new features with the code, and all those features they can add, all those enhancement that they can do. Why they can do? Because they are supporting modularity, they are readable and maintainable. So that means if new programmer will go and join certain company, they can read the program, understand what this function is doing, what this package is doing, what this section of line of code is doing, because it is maintained in a proper way. And then they can go and add their innovative ideas, new programming structure, new programming enhancement if something is there, that they can go and extend, add in that program. And that's why we have the modularity and reusability. Yes, because it is supporting the methods, function, classes, and modules, so it can be reusable. It is well documented, maintainable, so it has some sort of a structure, organization code, the branches, sub branches within the code, so it can be maintained easily, right? And apart from that, it has the encapsulation and abstraction. This is the common feature of object oriented programming, that you should have the abstraction and the encapsulation. And finally, the scalability. Scalability will be there if programming structure is good. From day one, if your framework is good, then you can go and add different modules within that particular program, within that particular package, right? So this is all about 1.5. In 1.5, it is expected that we should know these terms, because later on, once you go and develop your program, you should also keep these things in mind while developing your piece of code, your programming, right? All right, let's stop here. In this subsection, we have to understand about MVC and Observer. MVC is Model View Controller Pattern, and how this particular design model is useful. We're going to discuss about that. Now, if you know any of the SDN platform, for example, SD-WAN or maybe Cisco, ACI, etc., you know that in these platforms, we have some sort of controllers. We have control plane, we have management plane and control plane, orchestration plane, and then finally we have the data plane devices. Point here is this, that these devices, they are divided into different zones or different areas. Means we can segregate the devices as per their role, and we can define the role for those devices, and according to that they will work. Now if we go and analyze, compare MVC, model view controller, with the same approach, you will find that we have three pieces. We have something called user. What this user will do, that this will work as a front end, right? So user will work as a front end. this user interface. Front end means, for example, if you go to vManage or Cisco ICE, you will log in. Where you are logging? You are logging to the dashboard. You are logging to the policy administration node in Cisco ICE. You are logging to the vManage dashboard in Cisco SD-WAN. So user interface is the first where you are logged in. Then second, you have the controller. What is that controller? Controller is something related to handling the messages in between the users and the database. So if I go and draw three pieces here, box 1, box 2, and box 3, you'll find that your front end is nothing but the user. Your backend is nothing but the model, your database, your the storing servers and all. And in between the communication channel that we have, it is happening via the controller, user input handling. So in between we have the handler, controller. Now on basis of the such type of a structure, such type of MVC structure, if we go and design certain packages or certain modules or software, it will be very useful, right? And that's why if you go and use such type of concept, then you will see that we have flexibility related to code reusability. We can scale, we can do the maintainability, we have the parallel development, we have the separation of concerns. These things we have discussed in our previous section as well, when we are talking about the modularity, function, classes, and modules. So if we use such type of approach, you have the benefits related to modularity, reusability, readability, maintainability, encapsulation, abstractions, scalability and extensibility. All such features you will get with this MVC pattern as well. It will provide you all such features related to separation of concern, code reusability, scalability, maintainability, and parallel development. And likewise, we have the observer pattern. In observer pattern, again, we have some advanced options such as loose coupling, where you can go and define the subscription and the publishers and the subscriber, who is subscribing, who is doing the publications. Again, these are the uh, object-oriented design options that we have. Loose coupling, then we have the flexibility. Flexibility means uh, doing modification with ease within the software packages. Then we have event-driven architecture. We have customizability, means if you are doing something, you are getting some messages, and then you can go and edit, you can go and improve that code, you can extend that code. And finally, we have the manageability as well, that if some third person will come and check your code, he can understand everything and he can add some code, right? And you have nice defined piece of a structure, so manageability will be easy. That will go and reduce the risk to manage the um, code. And then if we have any changes, so changes in subject or observer logic can be made independently. So it's like something like risk free. One module will not go and do some functional changes in other module. Otherwise, if you have lots of interdependency, then if you do some changes in one part, it will go and reflect the changes in other part. If some problem in one part, the other part will also have some issues. All right, so my agenda was in this particular video is to explain you about MVC. It's not a new type of a structure. If you compare with today's world, we know that in the SDN structures, we have three-tier architecture. You have Web App DB. Web is working as a user interface, as a front end, and the back end is the database. And in between, you have some communication channel, that is the controller. So in terms of software designing and operations, the MVC, model view controller pattern, is something that is very suitable to the code, right? All right, so let's stop here. This will be the short video. In this video, we'll go and discuss about the version control. And in the upcoming section, we'll go and learn about the Git, that how we can go and do the operations within the Git GitLab. So version control is important because with help of version control, we have multiple controls within the software development cycle. What controls we can do? We have control over history tracking. That means that over the time period, what is version 1, 1.1, 1.2, means major and minor revisions that we have over the period of cycle for the software development, we can go and track that. We can have the collaboration, different engineers, DevOps engineers, they can go and collaborate, they can develop different modules, and even they can test as well. So we have the collaboration. We can go and have the branching option later on in the upcoming section. We'll see that how we can go and create the branches. So you can see the version control system supports branching for parallel development. That is also one of the important feature. Then we have the code integrity. Yes, you have the code integrity because once you develop certain code, you can take the backup, and we have the recovery option as well. So not only that we can take the backup, but if something will happen, something wrong will happen, then we have the recovery option as well. Code review option is there. We have option related to rollback and revert. So rollback and revert, we know that these operations, this rollback and revert option we have in normal Cisco router and switches as well, that if something will go wrong, we can revert back the configuration like that. If some code changes having wrong impact, then we have the rollback or revert option. Parallel development, one of the nice feature we are looking for parallel development, because different DevOps engineers can develop their modules parallelly. And finally, documentation. Earlier in the software lifecycle management options that we have, such as lean, agile, etc., there we have seen that how important this documentation is. Documentation is very important because if we have proper documentation, it will serve it has the project history, the forecasting, transparency, and the communication. So documentation is very important while developing the softwares. So now you can see that importance that we have with the version control system. With version control system, we have these many options, these many these many tracking options and improvement options and review, and the revert back means some recovery option, like good amount of options we have. That's the advantage we have with the version control. Now we have important section where we have to understand version control within the Git. Here you can see that as per our curriculum agenda, we have to understand about different type of configuration options, different type of operational configuration options, such as clone, add, remove, commit, push, pull, branches, merge, and handling the conflicts, and diff. So one by one, I have the configuration items for all these items. Later on in the lab section, we will check in the lab that how things are working. So here you can see that if you want to clone something, you can go, this is the GitHub repository, right? And from there, you can clone something from GitHub to your local system. So you have to use this keyword called git clone. And with the git clone, you can go and clone to your local machine. Then we have add remove option. Add, how we are adding the files. To add files to the staging area for commit, we are using git add dot or git add that file name. To remove the files from the staging area, we are using the rm keyword. So git and then rm and then the file name, that will remove that file from the staging area. Suppose if you have to go and update some sort of comments, so we have that option that commit changes to the repository, and we can give that commit messages. So you can go and give, say, a git commit -m, and then say task 1.3 completed, task 1.4 half completed. Like that, you can go and give the messages. Then we have push pull option, that we can have the local commits to the remote repository, right? So now we can go to the git CLI, and then we can use the git push origin main. Then we have to pull that changes from the remote repository. So for that, we can use the pull keyword. Push and pull. Push and pull we have there to push the local commits to the remote, to pull changes from the remote. Very easy and straightforward, right? Then we have few more, that to create a new branch, we can go and use git branch and new branch name. It will go and create that. To switch to a different branch, we can go and use the checkout keyword. So you can see the git is common everywhere, and then we are using different keywords after the git. So we can go and use the git checkout and the branch name. Then we have merge and the handling conflicts. For that, we can go and use merge and the source branch. If there are conflicts during merge, resolve them manually in the conflict files, add the changes, git add, and commit the merge git commit, right? So if conflicts are there, you can go and resolve those conflicts, and then again you can go and merge that, right? So these are the options we have. And finally, we can see here that we have the diff. So 1.8g, we have the difference between the files, how we can go and check. We can go and use the diff file name, or you can have the diff for commit #1 and commit #2, just to check the difference between the files, right? So these are the 7 operational commands the exam is expecting that we should know. You can say 1, 2, 3, 4, 5, 6, 7. So what we'll do that, let's go to the lab section where I have the git locally, and then I have the repository as well, and we can play around there. Let us perform the lab task related to git operation, how it is working. So I have my own cell in my local system, and I have the GitLab. What I want to do, I want to upload my local configuration to the GitLab. And even we know that from our previous video, that how we can copy the remote labs or remote folder to the local system as well. We'll check that. So first of all, what I will do here, let me quickly go and draw the analogy. So I have my local cell, and then I have the lab. Suppose this is my local Git shell, and then I have the remote lab. And at the moment I'm logged into the remote lab where the IP is 198.181.11. Let's assume that this is the GitHub lab or GitLab, where I have the remote repositories that I want to create here in my local CLI, and I want to upload there from my Git. All right, so let me quickly go and log into my local Visual Studio software. So here you can see that I have my local system where I can go and check the folder CML ISE, and inside that I have the configurations related to different parameters, right? So that is fine. Now what I want, that this configuration that is there in my local system, I want to upload to the remote system, that the GitLab. So here I'll go and create a new project, a blank project, and I'll give the name this as a CML ISE. You can see the project URL root under slug is CML ISE. Visibility is private, and I want to create the project. At the moment you'll go and create the project, you can see that we have handy configurations here, operational configurations here, global setup, that is the global username and the email address. Then create a new repository. So we can go and create the repository. That means that these commands I can go and run. So let me go and open this. Instead of administrator, I can go and give the name, say, and then you can go and give the email. Oops. Email also I can go and give the email as dot or at the rate and user dot email, right? Then you can see that we can go and give this command that from my local system I want to connect. So this is not something that we should give. This is something that you can clone to the local system from here. So this I don't want, but from my local system I want to log in to the remote lab and do the configuration. So let me quickly go here and do that. First of all, you should go and initiate the Git. Now the initiation is started. Now here you can go and check the help command. There are good uh, amount of commands are there, like for working area. Then we have the changes. Then we have the history and stays. Then we have the grow, mark, tweak, collaboration, etc. What I want here is this, that I want to give the remote command. Why? Because I want to add the origin, that is get 1.11, and even I can specify the port number. If it is required, I will go and specify that. So it is telling that origin is already there, so that that is good actually. So that is there. Great. Then let's see. So here you can see in the bottom we have this configuration that I want to add the origin, and if you have the specific port number, you can use it, because you want to push local repository to the remote GitLab. So even you can use those commands located here, or you can go and use this command. So because it is already existing, so that's fine. Now what I can do here, once we'll do this, we can go and let's see here. So now, okay, if you have any old origin, you can go and rename it. You can use it, and simply you can go and push this. If you go and use this push command, it will go and push. No problem with that. Even we have option with git add. So we have done the git init, and I can go and add this, right? Even you can go and use these commands as well. So let me quickly go and there's no harm using these commands, even the push command as well in the sequence. So I can go and oops, put like this. Okay, best. Wow. So now we can see that these commands is working fine. And if we go here, if we go to the projects, here you can see that this folder has been pushed, IAC infra and Civil test. So this lab is successful, that means we are able to push from our local system. So if I go back here to my local system, we are already here. If I do -a, if I do IAC infra, you can see that what files I have, and same things you can see there in the remote as well, right? Now, other thing I want to show you that we have this option called git clone as well. Since here we have the file called the CML IAC, what I'll do here, let's do this thing. Let me go to any of the folder. Um, just right. And now I can go here and do the cloning. So the command that you can copy the remote repository to the local system is this. Let me go back to the folder, main folder, from where I can go and copy this project. So let me go to the projects. Your projects, yes, we have this project, and I need the URL for this project. Commit is there, commit, and all those things are happening, and you can see a lot of things are there, like merge, repair, CI/CD issues, and all those things. But I need the repository. You can see that we have the repository. I can use clone with SSH, clone with HTTP. Let's try both. Git clone HTTP, and now you can see it is cloning. So now we are cloning from the remote location to my local system. And within the test, if it is cloned, then if we go inside test, we should have that CML ISE folder, and then we can go and verify that. Right. So I have shown you both the things, basic operational commands. So these are very important. At the time of creation of project, we got all those information that I will upload with the video recording. Just after this video, you will see those commands, and you can make your own notes. All right, let's just stop here. Good job. We have completed section 1. Now in section 2, we have to understand about the APIs. Clearly, you can see that we have point 2.1 up to 2.9, where we have to understand these API, their working, their flow, lab related to API, the authentication, security, and how we can integrate these APIs with Python script. So one by one, we will go and complete each and every task. 2.1, it is expected that we should go, first of all, understand the REST API request, and then how it will be used, means how we can go and use these APIs within the programming, how we can utilize this API. First of all, try to understand that what is API. We know that we have 3 different types of methods. We have CLI, command line interface. We have GUI. So CLI via GUI mode, via CLI mode, you can go and configure the devices. If it's normal router switches, you can use CLI, which is very popular. Later on with next generation firewall, with all these SDNs, we have the GUI option that we can go in the dashboard. We can log into the dashboard, and from the dashboard, we can go and do different type of configurations. Then nowadays, APIs, application programming interfaces, they came into the picture, and they become very popular. Why? Because API is generally machine to machine language. Now, if you go and check the CLI, it's like human to device interaction. GUI is also human to device, but whatever configuration we are doing in the GUI, behind the scene, it will go and convert that configuration within some CLI configuration, within some machine learning, machine language configurations. But APIs are something which is directly interacting with the machine. So one API can be input. So API input, it can be input, and whatever output you are getting from one API. So suppose API, with one API means it's an instruction. So the output for one instruction can be input for next API action. It's something like you can embed these APIs within different type of programming languages. For example, in our lab, we are going to use API integration with Python, and you will see that you can integrate these APIs, you can nest these APIs, one API, two API, three API, different types of API. For example, device configuration APIs, interface configuration APIs, doing some certificate management APIs, like that. So the power here we have in the API with these instructions, machine to machine instruction, is this, that it can be embedded within the programming language. And since it is embedded, since it is configurable, then you have the real power, right? So then you can do multiple tasks with one script. One script can run and it will configure 2000 devices, like that. All right, so here you can see that while constructing the REST API, we have some steps. First of all, you should understand the API documentation. You should identify the task. You should go and construct the request and send the request. All these four steps that you are seeing, I will explain you in the next slide. But yeah, if you want to examine these APIs, we have curl function, we have postman. In the next section, in the lab section, I will show you that you can go and use this postman. Actually, originally it is developed by Google. This is one of the program you can install in your Windows, you can install in your Linux machine, and then this postman you can integrate. Means I will show you that I have SD-WAN related postman folder. I can import that particular folder, the set of instruction within the postman, and with that instruction I can send the API's instructions. Again, we'll see that what instructions we have. API instructions to SD-WAN vmanage, and from where we'll get some output. In this, I will show you one example related to curl after one or two slides. And then later on in this section, in section number 2.0, we have to understand the Python integration to construct the API. Now, we have four different tasks. Read API documentation. Yes, we have these four important methods. We have get, post, put, and delete. Get means like show run, show command. When you are running some show command in Cisco devices, that is the get. You are getting some output. Post means that you want to do some configuration. For that, obviously, you need some body, you need some item. And here our data format will come into the picture. So for post, the payload, the body payload, maybe in XML format, JSON format, or any other data format. Generally for APIs, we have done this study earlier. We know that for APIs integration, we are using JSON. So later on, you will see that for post method, we are using the data format that is JSON, and then the importance of JSON will come into the picture. You know that the JSON is very important data format, and it will come here in the post. Even in the put also. Put means you are updating some configuration. You are doing some modification. This means you are creating the new object. This means you are modifying the object. Delete means you are deleting the object. So once you log into the API document, I will show you in the next session that I can go log into vManage API documentation, where I will get thousands of APIs and related to get, post means creation of object, put means update an object, delete means delete an object, like that. We have the methods, right? API methods. Then identify the task. Identify the task means what you want to do. You want to do post. You want to get. Get means retrieve the data. Update means this put method. So what you want? So now you know what are your resources, what you want to do with the resources, that is the task. And then construct the request. Constructions mean that you want to use what HTTP method, you want to see the result, you want to see the object, associated objects, you want to create a new object, you want to update the object, you want to delete the object, right? But while constructing the request, you have other things as well. It's not simply that API will go and construct anything or delete anything. You should have authorization, authentication, right? So you can see that we have to go and set the request header where the content type and authorization should be specified, right? Include any required parameters or data. Means obviously we have some sort of security mechanism while constructing that object, and then obviously what you want to do while creating that, you want post method, so for that you need payload. You want put method, for that also you need payload. Get and delete are like normal API instructions. And then finally send the request. Send the request, you can use curl, different languages are there, post, or you are sending this via the Python and API integration. In this we have one curl method in this continuation with this particular recording. But in the upcoming section, I will log into SD-WAN vManage and I will show you the Postman as well. And later on in this section, we have to understand the Python integration as well. So now here you can see that we are going to use all these four methods: read, identify, construct, and send. So read means that we know that we have all those methods. Then identify the task. Suppose I have to do some user creation. I want to create this user with this email and password, right? And my API endpoint is this. This is the API endpoint. This is the example URL. My method is post, and the header is content type application JSON, because this is the JSON I'm going to use, and the request body is JSON. So this is point number 1 and 2. And then we have to construct the request, and then we have to send it. So construction of the request and sending. So to send this request, we are going to use the curl method. Curl x post. Post is my HTTP or curl method. Curl method is post, and this is the API. The content is application JSON, and this is the payload body, right? So that means you want to create this particular object. Here you can see that X is nothing but the method, H is the header, that's the content type, and D is nothing but the data, that's the payload. I want to create such type of a user within this API users. Within the user group, I want to create this particular user with this particular method. So you can see that with help of the APIs, actually first time if you create it, you may find some difficulty, but once you start working on the programming's API Python integrations, you will see that it will become easier, because the API construction for one particular uh, management platform, for example, SD-WAN vManage, will be same, almost same for Cisco DNA framework, same for any other SDN framework. The point here is this, that you have to learn this technology once, and then you can apply to any SDN platform or the management platform which are API aware, which can understand the API. So I can learn this and I can utilize same type of concept, same type of methodology to 10 different places. That's the power we have with these APIs. So let's stop here, and next section we will check the Postman method related to SD-WAN, and we'll try to check some examples in that. Let us perform the lab task here related to Postman and the SD-WAN vManage plus Postman API. So here you can see that I'm using the web version of the Postman. You can go and use it. And then I have imported so many different folders related to APIs. In this section, we are interested related to our SD-WAN section. So if I go to SD-WAN, you can see that related to SD-WAN, we have, let me go here to this folder. We have authentication related APIs, we have fabric devices, policies, template, those APIs we have. So if I go to authentication, let me click to authentication. And if you check here, authentication post, authentication token. So for authentication token, you can see that we have the method. We have the get method. What methods we have? We have 4 major methods: get, post, put, patch, delete, and then we have the head and other options. But with this get method, what I want to get, I want to get the vManage data service client token, the token for that authentication. This is authentication token, but here you can see that IP address related to vManage and the port number is not set. So what I want to set the variable, the username, the password, the URL, those things. And here in the Postman, so this is something like first time you logged in and you have imported the folders within the Postman. Import the folders actually is easy. You can click this import, and if you have the API package folders, you can go and click upload. And then what will happen, that it will go and upload all those API related folders. Although I'm showing you here, but this way you can go and upload these folders. Continue in the background. It will take some time to get uploaded because we have the web version of Postman. The desktop version of Postman will be little bit faster than this. But here I want to create the token, but I don't have this the IP address and the port number because they are defined as a variable. So what you can do here, you can go to the variable section. You can see on top, no variables, no environment is set. Environment for these variables that I want to set. And if we have something, some environment that I can go and call from anywhere, I can go and copy and I can call here. Otherwise, we have to go and set that. I will show you that. So still it is unresolved because we don't have the variables and it is asking us to add the variables, add new variables. So let me go and add the variable 198.168.1.10 is the vManage IP and the scope is global set. So now if I go here, you can see this is this. And then for port is 443 and a scope is also global. So now we have this is the API, this is the full API with variable because Postman is working like this. Now I want to get that token. So I can click next. Got it. And you can see this 200 is for success method. Let me quickly log into, log into the vManage as well. So if you go to vManage, you can see that you can use this URL and the API docs. You can see this complete API documentation related to configuration, troubleshooting, management, operations, everything. If I click more, you can see the get method. If I go to configuration, you will see all post methods, put method, and all those things, right? Okay, let me go back to my Mozilla browser where I have my can get the devices details. This is also the get method because our variables are set. And if I can go here and see the output, let me go and see the raw output. So it is showing it is successful, and once it is successful, then you can see the result as well. That is JSON. That's great. That's good. I should see this. Let me go here and put the authorization, basic authorization, username and password. Username is admin and password is, let me go and send this. Yeah, so hmm. All right, so what I have done that I have changed the basic auth. You can see the admin and the password. And then we are running this get method to get the device list. So you can see in the bottom that we are getting the list of the devices now, right? And then what I have done, I have changed the variable as well. So the variable I set as the vmanage, the username and the password and the port number. So all these correct values, when I go and set in the vmanage, in the postman, it will go and contact with the vmanage, and it will fetch the result for us, right? So this is the way that we can go and get the output. Let me quickly show you the token as well, because last time not seeing any token. I can see the token, right? So with the postman, we can go and do the changes. But postman is something that you can use for testing purpose. You can go and test the individual APIs, and then later on you can take these information and integrate within your Python programming. 2.2, we have to understand about the common usage pattern related to webhook. I'm going to explain you that the use of webhook, and with help of webhook, how you can make your system, overall system, networking system, efficient. So let's understand the webhook and webhook workflow, how it is working, and obviously the benefits of webhook. Now, what is the webhook, and what's the methodology, and what's the principle behind webhook is, here you can see in the diagram that your network management system, maybe vManage or maybe Cisco DNAC, etc., it is connected with a webhook with different type of HTTP methods. That means that webhook and my network management system, NMS, they can communicate via some API callbacks or HTTP callbacks. What type of communication they can do? So either a webhook can be used to trigger actions or receive notification about the network events. So the network events, network, they are connected with network monitoring system or management system. Network can go and trigger something that will again send to the webhook. Webhook will get that notification. On basis of that, webhook can go and take the action. That I will explain you in the workflow. But this is the overall architecture, that webhooks can be used to trigger action or receive notification. Let me explain you more about that. So how this system works, you can see in this system, we have three different items. We have webhook receiver, network management system, and network devices such as routers, switches, firewalls. They can generate some events sent to NMS. NMS can send to webhook, and on basis of those incoming request that is coming from the network management system, webhook can take action as per the configuration that we will do within the webhook server, within the external server. Now let's understand the workflow as well. So here you can see the workflow point number one, that some event will occur at the network devices, some configuration change, some network issue, high traffic utilization, etc. Then NMS will go and detect that event, right? Obviously, network management system is there to understand, to detect those events, and then NMS, Network Management System, generate the webhook payload. So now with HTTP callbacks, HTTP methods, NMS and the webhook servers or webhook receivers, they will go and do the communication. So event happen, NMS will get that, NMS will generate the webhook payload, and then NMS will send that to the webhook. Now we have the webhook receiver that will get that payload, that event and event related information, and it can go and trigger the action. This is very key phase. Phase number 6, point number 6 is very important, that the webhook will go and take action. What actions it can take? So webhook receiver may initiate actions such as updating the device configuration, sending notification to administrators, logging events, triggering automation scripts. Like this is the solution. This is the automation phase, right? And then finally, obviously, you need some documentation. That means we have the feedback loop. So whatever action that webhook receiver has taken, or it has generated some response or some triggers or some notifications, that should be logged in the NMS system. So you can see that the webhook receivers and the NMS and the networking devices, how all these things are connected each other. What are the benefits we have? Yes, we have the benefits. Benefits we have with the webhooks. It will provide you real-time event handling automation. It has very simple integration because you are integrating via the APIs. It will reduce the manual intervention of a routine task. Manually you have to do some configuration, some changes, that will get reduced. It will improve the responsiveness. Why? Because now your network devices, your NMS and webhook, they are part of same system. Some event will generate automatically, it will notify to NMS, NMS will send the payload to the webhook receivers, receiver will take action, it will go to NMS and the devices, and then finally the NMS will log those events. That's the overall workflow. So obviously doing this will enhance the coordination and communication in between the network component and the management devices, right? So I hope that you understand the webhook, the usability of webhook, how it will be there, how it will be used efficiently to provide a real-time simplified integration and removing cost and routine task, manual routine task within the network, provide a stable automated network solution. All right, let's stop here. In 2.3, we have to discuss about the constraints consuming these APIs. We know that API, they are good, they can integrate with the languages, different languages, and then they can perform tasks, right? But obviously, when you start working on these APIs, you will see some constraints, you will see some restrictions, you will see some shortfalls, right? It is not something that you are building and it is working 100%. So these APIs, they also have some constraints, some limits. And while creating the API related scripts, we should know these shortfalls. We should know all these shortcomings or constraints, right? So let us list all those one by one. You can see 1, 2, 3, point number 1, 2, 3 in this slide. For example, rate limit, that suppose different DevOps engineers, they are doing a different task related to one NMS system, one management system you have, where you want to shoot out these APIs, and then it will give you the results. So you should not limit. You should not limit or exceed the limit. Should not exceed the limit related to shooting the APIs to the NMS system and making it disturb, right? We should have some limit, rate limit related to API consumption. So that is one of the piece. Second point is authentication and authorization. We have checked this in our previous video while we are doing the lab related to SD-WAN API. We have seen that without putting the username and password, we are getting some error. So not only the APIs keys, we have the tokens, we have OAuth tokens, means advanced level of authentication is also there, right? So we should provide proper authentication keys. That is one of the constraint. Then authorization. Authorization means that once it get authenticated, how much authority that system has. So authorization means that the authorization, the amount of freedom, the level of authorization, the access level that you are providing to the endpoints, to the network devices. In case if you're writing the code for network devices, how much authorization, how much access you are giving. So this is also one of the constraints. You don't want to give full access to all the endpoints, to all the users, etc. Then data format. We know that we have different type of data formats like JSON, XML, YAML. And if we have some incorrect format of data formats, so then the result will be wrong. Error handling. One of the very important aspect we have in the programming language is error handling. So what if you have integrated your API with some Python script, and in a script itself you have error? What will happen? It will break the loop. So suppose I have integrated 4 APIs, 3 APIs are input for one of the APIs that the final result I want to get. So 3 plus 1, 3 input API and 1 output API. And suppose if something will get break in between API 2 and 3 execution, then obviously error will occur. If error will occur, then how you are handling that error? That is also very important thing. Endpoint change. Endpoint change is also very interesting because time to time you will see that we are updating the endpoints. So you can see that the API may evolve over the time. Sometimes we are running API version 2.1 and then again we are moving to 2.2. Suppose you are moving your API packages, your API versions from 2 to 3. That is nothing but the API changes, because with the new version of the code, API may also get changed. So that is also one thing that we should know, that the changes happening in the NMS and the endpoint, what is the degree of change and what is the effect with that change. Versioning is also important. Again, the same thing that I was telling you, the endpoint change. Endpoint change means the network devices changing and the users for which you are writing the code, they are changing. And then the versioning related to API versioning itself will get changed, itself will get improved. So how it will go and interact with the endpoint. Security is one key constraint. You may have some vulnerability, you may have some API issue, you may have some HTTP protocol or input validation error, etc. So security is also one of the very important aspect while writing the code. It should be securely, so NMS should securely go and communicate with the end system. They should be properly managed, handled. Then documentation, we know that the feedback point documentation is one of the very important aspect in the in any software development field. And with documentation, we can create right action for right API, or right API having right action that should be documented. So in future, you can go and refer the documents. Then point number 10, you can see list of points at 10. So throttling and quotas means it should not throttle the quota limit and the request amount. So what is happening. So when we are running the API, they are generating the token, and that token you are using for certain period of time. So suppose you got one token for 10 minutes. Within 10 minutes you have to complete the API, and the script should go and complete that task. If suppose it will not complete that task within 10 minutes, then you will get some authentication error. You will get some API error. Why? Because you have some quota, you have some time limit, and you are not executing the time within that time limit. So your script should regenerate that token. So your script, you should write a script in a way that after 10 minutes, if it should sense, oh, 10 minutes completed, 10 minutes completed, I should go and regenerate the token, and then I can rework on that API. I can rework on the program from that particular point of time where my quota limit, where my allocated time limit is exhausting, right? Like that you should create the API. Now finally, okay, so I don't have the summary slide. Summary slide is something that this is the next point. That is the next video. So what you can do here, yeah, here we have the summary slide. So what I have done, the first slide is the summary slide that you can make notes. So we have the rate limit, authentication, authorization, data format, error handling, endpoint change, versioning, security, documentation, and throttlings and quotas. These are the constraints we have related to API. 2.4 is kind of important video because in this 5-minute video, we are going to discuss about HTTP response code related to REST API, and that this particular 5-minute video may be useful for you with respect to your interviews. In interview, the interviewer may ask you that what is the use of 403 code. Means while you are running the code, you're running your HTTP code or REST API embedded within HTTP methods. And suppose if you are getting 403 error code, then what is the meaning of that? Suppose if you are getting 500 error code, what is the meaning of that? So here you can see that I have listed those methods here as the within the table you can see 1 2 3 4 5 6 7 8, these 8 very important HTTP status code. One thing we know from our earlier inspection that 200 means okay. If you are getting the message 200 response code 200, that means your API execution is successful, everything is there correct. Successful request, for example, retrieving the device information. So in this table, you can see that I have the HTTP code, a description, and Cisco related example, and some emojis like, right or wrong, etc., etc. But you can check first and second and third column related to the status code and what is happening with these codes. So 201s mean resource created successfully. That means you have successfully created the VLAN. 400 bad request, malformed request or invalid syntax. 401 clearly you can see this is unauthorized, authentication required or invalid credential. 403 request refused due to lack of authorization. We are deleting something without permission means you don't have the authority to do that. You don't have the authorization. Here you can see 401 is unauthorized action. 403 is you don't have authority to do that. 404 not found. Request resource not found. Not found. Assessing a non-existing endpoints. Don't know, don't know, don't know. Then 405, method not allowed. Unsupported HTTP method. Using post instead of get means using A method instead of B method. Like, method is wrong. 500, sometimes you'll get this 500. Unexpected server error. Configuring issue or some software bug. Yeah, it may be some bug, it may be some network issue for this 500, but yeah, 200 is good. Anything is starting with 2 is good. So 200, not all the time. 200 is good, 203 is good, 400 is bad. So 400 is bad, all the 400 is bad. 4xx or 40x is bad. 500 having some bug or some other issue. Again, the same thing here in some shorter format. So you can see that 200 is good, 201 is also good. Then you have bad request, unauthorized, forbidden, not found, method not allowed, and internal server error. After that, what I have done that I have given the detailed explanation that 200, 201, 400, 401, the same thing. Actually, you can refer this table. This table is good. Understanding that 200 is good, 400 and 500, they are bad. 400 basically related to some authentication authorization issues, and 500 is related to some unexpected error. Even 405 is unsupported HTTP method. And then you have the notes just for your reference. I have created these notes. Even you can pause the recording and take the snapshot if you want, or anyways, you have these documents access, right? So you can present or you can make your own notes. Then 403, 404, 405, 500, like that, we have all those methods. All right, so let's just stop here and you can note down these methods. These are actually important for your interview questions. Good job. We have completed up to 2.4. In 2.5, we have to understand the problem related to HTTP response code, request, and API documentation. So let's understand this. When we are talking about HTTP response code, it has response code. And let me show you that response code that we have discussed earlier in our previous recording. And let me show you the response code related to HTTP. Here you can see that we have the HTTP response code that anything is starting with 2, 200, 201, that is good. And then 400, 400, up to 405, you can see that bad request, unauthorized, forbidden, not found, method not allowed, and then 500 is some internal server error. So if we have such type of responses, that means that it is not correct. So while doing the troubleshooting, we should go and check the response code, that what type of response code we are receiving, because if we have such type of response code, that means that something is wrong and we have to fix it. Then we have to go and review the request details. So what type of method we are using? HTTP method, get, post, put, delete, because with post and put type of methods, you have to give some payload. So that payload that we are giving is correct or not, the method that we are providing with that particular API is correct or not, we have to go and check that. So point number 2 is review the request details. Then point number 3 here is the consult the API documentation. We should go and consult the API documentation, because all those frameworks, they have their own APIs, the list of APIs, and which API is doing what, that we should understand with the API documentation. So we should have thorough knowledge of the API related documentations. Point number 4 here is check for misconfiguration. Misconfiguration means that while creating that particular API, and suppose if we are inserting or if we are using that API within the Python program, so we should go and check the format of the API, the documentation, including the headers, parameters, payload, authentication method, all those things properly. That means the building of API and insertion or integration of API within the Python programming or any programming language, that should be in correct format. So here you can see point number 1, 2, 3, 4, that identify the response code, review the details about your API and API integration with programs. The documentation, you should follow the documentation properly. Check any misconfiguration is there or not. Then once we have this, we can go and check the response detail. So while getting the response, if we are getting any error, if we are getting any type of issue, such as the API limits, such as some pagination issues, etc., we should go and analyze the response detail. In the response, what you want in the response and what you are getting in the response. That is very important. Now, while shooting these APIs, while running this script that is integrated with the API, if you are not getting the proper response, do you have any network congestion? Do your NMS system is reaching to the network devices properly or not? So that is also very important to know. There are external factors such as network connectivity, slowness, reboot of the devices, unreachability of the devices, etc. So that also we should take in consideration while doing the troubleshooting. Then point number 7 is this: implement debugging techniques. Yes, this is actually very interesting, that we should know the debugging techniques, the logging techniques, the API response capture techniques, because suppose if we have 200 lines of code, within that we are using 10 to 15 APIs, you should know that API number 6 or maybe 7 or maybe 8, there you have some problem. So you can insert a small piece of code there, that if this response is not coming below this API, this message will indicate, or this logging message or this debugging tool message, that will indicate you that the API is working correctly or not. Finally, we have testing and the validation. So after doing all those built up, built up means identify the HTTP code, review the request details, consult the documentation, check the misconfiguration, and then the response, analyze the response, consider the network factors issues as well, that is the external factor, implement the debugging tool, debugging techniques. Finally, we have testing and validation. Within testing and validation, make sure within te- make sure that you adjust based on analysis, retest the API, request to confirm that the issues has been resolved and the expected response is received. That means the final stage is obviously the testing and validation, that whatever you have done so far is correct or not. You should validate it properly. Here you can see that the flow chart starting from 1 to 8, that is HTTP response code, review requested details, consult API document, check for misconfiguration, analyze response detail, consider network services and issues, implement debugging techniques, and finally testing and validation. So from a start to end, you should go and check all these validation while troubleshooting the HTTP response. All right, let's stop here. Let us continue our knowledge that we have studied in 2.4, 2.5, and continuing here in 2.6. In 2.6, we have to identify, understand the part of HTTP response. Here you can see that we have three parts. We have response code, header, and body. Now, about this response code, we have discussed in our previous video as well, and we have the graphics, we have the table as well, that if anything is starting with 200, 20x, that will be successful, 40x, that will be some error, and 500 is some internal issue. So here you can see that summary of those, that particular chart. 200, 201, 400 means some bad request, unauthorization, forbidden, not found, method not allowed, and 50 is some internal server error. So in this response code, HTTP response, we have three parts. One is the response code. As per the response code, you can go for the next step. Now, because we are studying the different parts of this code, so the next part is the headers. Let's quickly check the header. Now, this header format, you can see that common header include content type. Specify the type of content in the response code is application/JSON, text/HTML, and others as well. Then cache control, the caching behavior like max age, no cache, set cookies, setting the cookies to the client browser, and the authorization. So these are the headers we have. In the header, mostly we have the content type, cache control, set cookies, and authorization. And then finally, the body part. What is that in the body? The response body contains the actual content returned by the server in the response to the request. Now, if I show you the example, and if I go and add part 1, part 2, and part 3, then you will understand more here. So here you can see one of the lab example where we have the request. So you can see that we have the response code, right? This is the part 1. Then you can see the header. In header, we have the content type, we have cache control, we have set cookies, and the example for that. And then finally body. Let's suppose if I want to create one user with ID with email address. This is successful. Why? Because the response code is 200. Let's check one more example. In this, you have some error message. Here you can see that your request response, the part 1 here. Then you can see header. In header, we are using only the content type, that is application/JSON, and then the body that is returning the error. Right. So likewise, we have these three parts. In these three parts, we have the response code, header, and body, and all those three parts, we have different significance for all these three parts within the HTTP response. All right, let's stop here. This will be the short video 2.7. We have to understand the common API authentication mechanism. And obviously in upcoming days, when we'll work on API and Python integration, you will understand more about these authentication mechanism. I can see that we have mechanisms such as basic, custom token, API tokens. Now, basic is something that you will go and provide the username and the password. And if you want to hide the username and the password, you can use this base64 encoded. So someone can see your script, but they can't see your username and password. It's like that, hiding your username and password. But this is the basic methodology to provide the username and password. Now, even before reaching to this point from our previous discussions, we know that what is the format of the API. So we have the request body, we have the header, and we have the body where you have the actual expected response for the request, right? So 1, 2, 3, you can see 1, 2, and 3. So likewise, you can build your API script integrating with any programming language, but in the authentication, we have options related to basic, custom token, and API. So likewise, we have the basic, likewise, we have the custom token option as well. You can see that authorization custom token option. In this case, the authorization header contains a custom token generated by API provider for the authentication purpose. And finally, we have the XAPI key. This is something that is also type of token, but this particular API is included in the custom header XAPI as part of the request to the authentication, authenticate the API consumer. So the method, the body, everything will be the same. Only thing here is this, that the authentication methods, we have the basic, we have option for custom token, and we have option for API keys, right? So adding all those three, you can go and build your API, and it depends upon the level of security that what type of token you want to generate. And once you generate the token, what will be the lifetime or the expiry time of this token as well. If you are integrating one system to other system, suppose my SD-WAN, I want to integrate with AWS or any of the cloud. At that time, I need these API keys that the AWS or Azure, they will provide me API keys. So within the SD-WAN, I can use it. Or suppose your SD-WAN, you want to integrate with Cisco umbrella. So within Cisco umbrella framework, you will get some API keys that you want to integrate or you want to paste within the Cisco SD-WAN vManage. So SD-WAN and vManage, SD-WAN vManage and Cisco umbrella can communicate, right? So basic, custom token and API keys, they have different use cases, and they are utilized at different places. We are doing good. Now in 2.8, we have to do comparative study in between common API styles such as REST, RPC, synchronous, and asynchronous. Now, it's kind of interesting that RPC, they are very much similar to synchronous API method. So what I am going to do here, that let's quickly check the similarities and differences in between synchronous and asynchronous mode, and then we will check the REST and the RPC methods. So how this synchronous mode is working, you can kind of analyze this or correlate this with client server model, TCP client server communication. So what is happening, that you are sending some requests to servers and you are waiting for some acknowledgement, and then you are start doing the transaction. It's something like acknowledgement based communication. And what is in case of UDP based transfers? In UDP, you are sending, you are not waiting for acknowledgement, right? Means you are keep sending and you are not worried that something is lost in between. Like likewise, the synchronous is, they are sending the request, they are waiting for some response, and then it's like two-way type of communication. And that's why concurrency is lower and the latency is lower, because you are waiting for some response and then you will send the reply. The example for this is HTTP-based REST API, SOAP services. Now, on other hand, the asynchronous mode is something that they are not waiting for responses. So that's why they are non-blocking. Their latency is higher. Concurrency is higher. On the other hand, concurrency is higher. Why? Because you can send the packets. Examples are WebSockets message queues like RabbitMQ and Kafka, right? So obviously different methods are there and different methods are being used at different processes. And that's why you can see here the communication style and latency. On other hand, let's quickly go and check the REST and RPC as well. So if I go to the next, you can see the REST. Representational state transfer, they are using HTTP methods. They are statelessness, uniform interface, cacheability. The examples are web services, cloud APIs, supported data format, JSON and XML. Actually, we know this thing. Whatever examples and the body structure we have studied in our previous sections, previous sub videos, small videos, they are very much suitable for the representational state transfer REST APIs, right? Then we have the RPC. RPC is very much like this method, synchronous APIs. They are also very much like client server model. They are working on that model. And you can see client server model with synchronous communication used in distributed system and microservices. That's the usability of the RPC method. And finally, again, just to summarize the synchronous and asynchronous methods, you can see the synchronous method. They're working as a client server. Immediate response is needed because once you get the response, then you will reply. They are following the request response pattern suitable for real-time interactions. Asynchronous, on the other hand, you can see that client can continue execution without waiting, delayed response possible, used for long-running task batch processing, that is RabbitMQ and Kafka. That is the example for this, implemented with callbacks and promises. Right. So this was the actually short video related to different type of methods that we have, and then I put here the summary chart that in table format, so you can see the communication style in between the REST, RPC, synchronous and asynchronous. The communication style is HTTP, RPC is procedure or function based, synchronous is request response pattern, and asynchronous is event driven non-blocking. Then you can see the interaction methods, the statefulness. You can see this is RPC is a stateful, can be a stateful or a stateless. It's like in between. And synchronous is a stateful, like TCP, a stateful inspections. Let me is a stateful transfers of packets, and this is a stateless, very much like UDP type. You can analyze. Then the data format, the rest they are supporting XML and JSON. RPC depends upon the implementation, synchronous any format, asynchronous any format. So some similarities are also there, right? Between synchronous and asynchronous. Then use cases, you can see web applications, distributed system, real-time interactions, long-running tasks for asynchronous. And finally, the architecture for REST is RESTful architecture, RPC is client server, and this also client server. So RPC and synchronous API, there are similarities in between them, right? And this is very much different. This is like for system to system or within the system type of um, communication. The example for asynchronous is actually very interesting. Long running task and batch processing, very much used within the system within the system, right? So here you can see that the architecture is event driven non-blocking. This particular slide, you can pause a recording and you can take notes. This is the summary slide for all these common methods. All right, let's stop here. Now we reach to the last subsection of this section, section number 2, where exam is expecting that we should go and integrate REST API with the Python script using some libraries, using some request library, right? Now, at this point of time, suppose if someone doesn't know Python, how Python is working, then it will be difficult for him to understand this lab that I'm going to show you after this video. We have some videos related to lab task, but Python is not that difficult. If you start learning Python, maybe within 10-15 days, you will understand the basics of Python. What you do, go check any ebook or any video series related to Python and try to break that in different part, like what is Python data structure, what is Python functions, what is Python modules, what is file handling, error handling in Python. Like, you list down these topics, like divide it into 6 different part: data structure, conditions like for while loops, then the functions modules, then the file handling, then the error handling, and then some of the examples like that. If you can go and divide Python in 5 6 different areas, and if you try to learn it, it will not take more than 15 days to understand it. At least the basics of Python you will understand. And once you start developing your programming skills, once you start learning more and more and more, then obviously automatically you will understand Python programming. Now, once you understand the Python programming, then where you can use it. So you can use in network automation, you can use it with the integration that we have here, RESTful API integration with Python. Right. So learn once, and that principle will be utilized at different areas. Nowadays, people are using Python in machine learning and AI as well. So it's like open area. You can learn and you can use at different places. Now here we have one example. You can see that we are importing the packages called request and JSON. Request is basically for authentication purposes. Otherwise, it will go and throw some error, right? So part one is here that we are importing some packages. Then you can see the notes here. This is comment in Python language, means this will be hide for the from the programming, and this will be in effect. This is the code. These are the codes. These are the codes, and these are the comments. So then a DNAC API endpoint and credential. This file that you can see here, this is the DNAC URL, username, and password. In the upcoming lab section, you will see that this file I can store anywhere, and then I can import it from the header. Say import DNAC credential file, like that. I can save it anywhere in the same folder, and I can import it because I don't want to show what's the username and password in the same location. So this can be imported, right? Then from our previous knowledge, so if I go back and if I show you the examples, that 1 2 3, you can see what we have. We have the request, we have the headers, we have the body, right? We have the request, we have the header, we have the body. Like that, if you go and analyze these programs, so you will see here that we have the header, right? Obviously, request is there where we are putting the authentication parameters and all, but you can see the headers closely. Header, content type application JSON, accept application JSON. So this I want to accept. This define header for authentication and the content type. Then you can see that my actual authentication and token program will come. This I'm going to show you in the upcoming section, the lab related to this, and I'll generate the token and I'll show you. See, token got generated. So this, you're generating the token, say auth endpoint. This is the DNAC auth. This is the API auth token. You are generating it. Then you are putting, so you are firing the see auth endpoint. And this is one line actually, because I have less space here. So these two are one line. This is one line. So this is something like this: auth response equal to request dot post auth endpoint comma auth username password. So what I am doing basically, that with API, with help of API, I am calling the username and password from here. With that username and the password, you can see that username, password, and the headers verify false, the certification verification false. So for with that, we are generating the token, and then we are storing that token here within the auth token. Why I am storing that here in the auth token? Because this API result, the part of this API result, I want to use in my next phase. What is my next phase? My next phase is to get the network devices, list of the network devices, right? So to get the list of network devices, this is the API. device endpoint. Now the response is the request.get method. Get means show the network device output. Again, this is also one line. So you can see that we are sending the response, and these things we have studied from our previous videos. If you watch that closely, so in our RESTful API method, what it is based on client server. You are sending some request waiting for response, right? So response, why response? Because in that response you have XAuth token. Remember, this also we have a study. We have a study about the authentication, basic token, XAuth token, etc. in our previous section. So X auth, so that's the header, verify is false. So what is happening? The token that we are generating here, we are utilizing the token here, right? And with that token, now you can see the condition. This is a print statement. So we are storing something within the device response, right? Now we can go and print it. So device response, you can see the condition related to device response. So if device response is successful, 200 is what? Successful. Then device data equal to device response.json. Your data format is in the JSON format that you are storing where? Within the device data. And then you are printing that JSON dump with this intent value. So it will go and print all the device list one by one. If this API firing will have some issue, right? Maybe network issue, maybe API issue, maybe code issue, maybe any type of issue, then this else statement will come into the picture and it will throw error. Sorry, I can't do this. Right? Means you will get this error statement actually, error fetching device, this. So this is full-fledged example related to how you can go and embed the API call within the Python request, Python program. And although it is like maybe 20 lines code, but you have to understand Python, function, error handling, so many things here, right? So many things you have to understand to reach up to this point. What I have done, that I have created 3 videos. After that, you can watch these 3 videos related to, first of all, what is DNAC API? Someone is not aware about DNA and their API, how the API is working within the DNA. Short video related to DNAC API, short video related to DNAC API, and then one video related to actual firing the lab. And in this video, you will see the lab URL as well, where you can go and perform the lab task as well. These URLs, if you go and watch video number 23, you will see that the Cisco Open Sandbox, where you can actually execute this program, run this program, and you can get the result. So I have shown that in this video in the lab with the lab scenario. You can understand with the lab. So up to this, you will see in this, and then what I have done, I have printed the token. Now once you have token, then you can use anywhere like getting the network devices or any type of operation, because you know that APIs are something that can be input and can be output, and the output for one API can be input for other API. Okay. All right, so please go and watch these 3 videos, and then we are completing section 2. Now coming back to DNA RESTful API, here you can see first of all the overall structure of DNA, where in bottom you have intent-based infrastructure, where you have the endpoint devices and all IT related devices, correct? Then we have the DNA center, that's the software that is going to glue the intent-based infrastructure and the open platform. Now when we are talking about open platform, that means you can go and uh, integrate with so many different type of open available softwares. Obviously that will increase the agility, and that will increase the performance of DNA in terms of when we are using all of the capabilities. So obviously the total cost of ownership will get reduced. The overall end-to-end network optimization plus visibility will get very much improved. Now here you can see that we have integration with the IT management tools, say for example ITSM, IPAM, Infloblocks, etc. Third-party integration is there. We can go and connect with the SD-WAN, ACI, security, stealth watch. Those are used inside the security monitoring. But even a stealth watch is doing more than that. Even a stealth watch can take the input and send somewhere for further analysis or other stuffs as well. So, but overall, we have the integration with other domain, cross domain as well. But where is the intent? Now, intent you can see an intent based API you can see on the top where you have the business and network intent, where we have the application, policy, assurance, plug and play topology, wireless provisioning, network discovery, software management, etc. So the list is long, and here we are using the API. At this point of time, we know that when we are using a RESTful API, obviously we are doing HTTPS call, and the methods are, say, get is something like show command, means you are getting the output or result. Post if you want to create a new object. Put if you want to update object. Delete means if you want to delete any object. Okay, so means the important thing here is to understand that whatever technology we have, either it's a ACI or SD-WAN or DNA, every year you'll find that same type of a structure is has been used for RESTful API. So once you understand the API and the calls, then that is applicable for all the cross network domain or all the other domains where this API, RESTful API, is going to be used. Now again, if we use this approach, overall uh, cost of ownership will reduce, the optimization for network will improve, and again we can add or we can have new capabilities in the network. How we can do that? I'll show you. I'll log into the DNA and I'll show you that where you'll get it. But if it is a new installation, you can go to the software update. So here you can see that we can go to software update, and then we can go and install the software update. Here in the bottom you can see that we have the updates. Now once you do the installation, then you should go and enable the DNS Enter REST API. Once you enable DNS Enter REST API, then you can go to the development toolkit. Inside development toolkit, you can see now you have the get, post, put, all those methods. Suppose if you want to check the health of the network or the health of the devices, so this particular first API get site health, it will give you the health of site, return overall health information of all the site. So once you do this get method, means you want to see, this is something like show command. If you want to see that health of the network, you can go there, click run, and then it will go behind the scene. This particular API will run and you will get the output. So here in case you can see that you are going to use this REST API, where you have the DNA intent API version 1 network devices, and then you will go and as per the query you will get the result. Now while you're getting the result, if the code is 200, that means successful. And likewise, you have all the codes here. So for example, 403, that means server recognizes the authentication, but client is not authorized to perform the request. So likewise, we have all these success code, the messages. A success code is 200, but suppose if you are running the API, and how could you know that which particular state you are in? So if you go and check these codes, you'll come to know that up to which particular point you have any issue related to REST API. All right, again, so here you can see the model schema for the API, and you can go and click run, and you will get the output in the JSON format, but again you can convert the output as per the desired. All right, so let's stop, and next section I'll log into DNA and I'll show you that where you will find this API. All right, so let me show you that how you can go and verify any of the API. So once I log in inside the DNA, Here you can see the dashboard, and it's quite robust. You can go deep inside the DNA dashboard and you can see so many things here. So what we want to do here, that first of all, let me show you that where you'll get the information about the API. So here you can go to the document section. Here you can see that you have the API references. You can open this particular page and you can get the information about the API. Let me open this and let me show you this particular page, that once you open how it look like. So here you can see that developed by DevNet, and then you can go and see the intent-based APIs, and there's so many revisions and you can learn a lot from this place, correct? So you have the SD APIs, how it is going to work, what are the methods we have like post, get, put, delete, etc. Each and everything you can go and understand from here in detail. So this is the documentation page for the DNA API. All right, so let me walk you through that. If you are doing this first time, from where you have to go to enable it and then how to use it. So for that reason, you can go and check the platform. Once you are inside the platform, here you can see that you have the bundle. Now in the bundle, you can see bundles are easy to use feature set for consuming intent-based API. So if you go and click there, now here you can see that suppose your API, REST API is not active. So what you have to do, you'll get one button called enable. You can click there and it will get enabled. So for example, ITSM service now is not enabled, and other integrations are also, you can see that not enabled, but our RESTful API is enabled. If it is not, you can go and click enable it. Now once you do the enablement, then on the top you can see that you have the manage bundles and configuration. You can just go and verify the configuration as well. But if you want to check the REST API, so for that you have to go inside the developer toolkit. Here you can see that you have the developer toolkit and API. You can go there and then you will get the RESTful API related to authentication, know your network, site management, connectivity, operation task, policy, etc. So suppose if I go here and click know your network, and inside know your network you can go and check the site, topology, device, clients, user, etc. Then site management, you can go and check the site management related stuffs. In policy you can go and check the policy related stuffs. Again you can see the color coding is also there, and that's true for all these methods in most of the API runner. So for example, SD-WAN we have Swagger where we are running the APIs. So here you can see that the green yellows for get and then put and then post and delete is red. Okay. So what I want, suppose I want to know my network, and say for example, if I go to topology, inside topology, I want to know that what type of VLANs I have. So here you can see this particular API will run. Let me go back. So here you can see that you have this get the VLAN. You can go and click here to this blue get VLAN detail, or you have three dots. You can go here and then try it. Both is okay. You can go to any of the place and click it. So now you can see that the public URL, and you want to run this API, and success code is 200. That means correct, and then you are getting the response. So all the VLAN in your infrastructure you are able to get from here. If I go and click here also, so here you can see that this is the API, and again it is telling all these codes that we have seen earlier. Then here you can see that route map option response and version. So here you have little bit much more output, and that is adding the model schemas as well. Now again, if you run, it will go and reach to this place and you'll get the output. Okay, so this is the way that we can go and execute the API, and we can go and check all different methods as well. Let us check about our lab. So the lab you can go and use Cisco sandboxes. Here you can see the URL, username and password. Two sandboxes are there: sandbox DNAC cisco.com, sandbox DNAC2 cisco.com, and you can see the username and password. Definite user is the username and the password. Now this is the lab, and we are going to run our APIs with respect to this lab. Plus, when we built our post related APIs, we built our delete related APIs, then I will use private sandbox, a private lab, and at that time I will show you that the lab topology and other stuffs. All right, so now we are ready for our first program, and that is related to authentication API. Now, what is happening that suppose if you're running the APIs for certain task, at that time you need some sort of authentication token, means you are the valid user or you are the valid API user. Once you have that token, then using that token, that will be associated with other API, other task related APIs, and we can execute certain task. Correct? So I'm going to show you this post method, that how you can go and get the tech token. I am going to show you the token as well, that how with the program we are going to generate and get the token. Now in upcoming sections we have to learn and execute so many different tasks, such as site management APIs, know your network APIs like client, your devices, client sites, etc. We have the command runner, template runner APIs as well, discovery APIs, connectivity APIs, etc. So long list of APIs are there that we have seen in earlier videos, and in the upcoming section we are going to learn about that. Now for lab 1, or for the first program that we are going to execute now, what are the things we have? What are the programs we have in this program? Now you will find that we have actually three different type of Python program. So one file I will show you, config.py, or you will see that I am going to use a env underscore lab.py. Basically this will be one small Python program where I have stored the DNAC URL, the username, password, port number, etc. Now this is a variable file, and suppose if I'm going to use this variable file, so suppose this is the first program, and second program obviously I have the library API or library Python program. I will show you that the library name is DNAC underscore API dot py, correct? And third thing that we have is the main program, correct? So main program. Now connecting program number 1, program number 2, program number 3, we will execute a certain task, correct? So what I was telling about that program number 1, that is the config or environment lab, env lab.py, that this will be your variable. So you are not going to do any change inside your library program. You are not going to do changes inside your main function. Means obviously you have to generate and develop your program, but once you develop your program, then if you are running those program, what is the reference, which particular DNA you want to run? You want to run with respect to sandbox 1, you want to run with respect to sandbox 2, or you have any private or enterprise lab or network, correct? So that's the thing here, that's the scalability here, that the environment lab, we have to change the variables, and once we change the variable, then the library and the main functions will be as it is. Now in future, if we have the library, so suppose in future, if we have a new task, correct? So suppose if I have new task, then you can write your program. I'll write PR as a program, and then that program will point to the library.
So that means inside the library, I have to go and create new function like function 1, function 2, etc. And then in the program, while the program will go and call that particular function inside the library. Correct. So you can see the reference point here that you have something called the variable, and then the variable is referenced inside the program, and program is referenced by the functions inside the DNAC API or the library. Correct. So let me quickly show you the program first, and then we'll go and proceed according to that. So here we have the program, and here you can see that I have my main program. What this main program is doing, that it's although it's a small program here, and inside this small program, let me take the drawing tool here. Let me take a pen here. Yep. So here you can see that I'm importing certain packages. So import datetime, time, request, JSON, URL library, all these functions or all these packages that I'm importing is not required for this particular program. Okay, but what we need to import the URL library, and from request.auth the HTTP basic auth, and again from URL library 3 exception import insecure request warning, otherwise whenever you run the program it will generate some sort of certificate errors. Correct. And then finally, so what important things we are importing here, let me clear the drawing. So we are importing, very important thing here is the DNAC APIs, line number 15. And then we are importing the DNAC URL. You can say URL, the password and the username. That's the line number 16 from one of the function, one of the Python program, that is environment underscore lab, env underscore lab. Correct. Now you can see the main body here. So the main body here, it's get the token. So DNAC auth is the name, and this DNAC underscore auth is calling something from the DNAC API. So you can see that DNAC underscore APIs is my library Python program. It's a big program. From there, we are calling one function, that is get underscore DNAC JWT token, and then we are printing that token. And that's the whole idea about this particular program, is that we want to print the token. So you can see the program itself is only of 2 lines, but you can see the overall structure of the program, where we are importing certain packages or functions, then we are defining the main function. Inside the main body, we are writing our sub function or sub routines, and then finally we are closing the main function. Correct. And this is the overall structure of the program we have. Now what we can do, that we can go and refer the other programs. So let me quickly show you the variable that we have, that we are calling actually. So that name is environment lab. And now here you can see that the DNAC user, the port, username, URL, password. And suppose if in future I will use some private lab section. So here you can see this is my private lab section credentials that I will use in upcoming sections as well. And because we have used this comment here, that means they are not used. Means in Python, if you use this pound symbol, that means they are not used inside the program. And then finally, we are referring our main function. This is the library function, and you can see this is a big, so many lines are there, but again we will learn understand this in future more and more. So we have already understood the import functions that we have, and then you can see that we are calling this function, and in this function we have the API for the token. Correct. So let me highlight those things. Let me scroll a little bit down, and let's check the API related to authentication token. So the API related to authentication token is API system v1 auth token, that was there in the slide as well. Then we have the header, and then we have the response where we are using the post method, and that's the key. So we have different methods like get, put, post, and delete. So we are using this post method, and from the response, so you can see that from the response, we are taking only that field related to token, and then it is returning the token. So this is one of the classical example that how we can build a function with argument. So what's argument we have? The argument we have is the DNAC underscore auth. Correct. So now this is the execution time. I can go here and my code is inside this particular folder. So simply I can go and run that code. And what's the program name we have? The program name is get token py. So I can go and use get token py. So let me write that. And now behind the scene the query is happening and we are getting the valid token. Now this token is belonging to which particular sandbox? You can see here the sandbox is sandbox sandbox DNAC, correct? And suppose if I make this 2, and if I go back to the program, because that is the different sandbox, so now you can see that this time it will generate a different token because this is belonging to different sandbox, correct? You can see how easy this is, but there are so many baby steps involved here, and this is the same way that in future we are going to build our programs, correct? So let's stop here.